Okay, in the previous lesson, we have learned about trigonometry, which was related to measurement of triangle over there, trigonometry. Today, we are going towards a little bit practice of exercise questions and understanding what he is basically telling us and how we will go for properly using the trigonometric ratios over there. For example, here he is showing 15.4 exercise for each of the following triangle. Write down the letters corresponding to the length of hypotenuse and the values of opposite and adjacent. If angle A is this, then this is opposite, this is adjacent, and this is hypotenuse. In front of 90 degree, it is hypotenuse. Opposite to this angle A is perpendicular or opposite, and adjacent side is called adjacent over there. Same as it is 90, where P over there is hypotenuse. For angle A, R is showing here as adjacent, and opposite side of Q is showing as opposite over there. After that, for angle A, opposite side is present in the form of N over there, and L is showing in front of 90 degree is hypotenuse, and for M is adjacent to this angle, so it is the adjacent side over there. For C, it is again hypotenuse, and for D, it is opposite, and for E, we can say it is just adjacent to A, so it is adjacent side of right-angled triangle over there. E is hypotenuse, and G is adjacent to the angle A over there, so it is adjacent, and F is opposite over there. After that, here he is saying that in case of copy, that we will say here that if he is asking opposite 30 degree, opposite 30 degree is 5.7 centimeter over there. Here he is saying opposite to 40 degree is x centimeter, adjacent to 50 is also x centimeter over there. After that, Q meter is opposite to 65, opposite to 65. For 25, P meter, 25 for P meter is also opposite, and R meter is hypotenuse, are opposite to 90 degree over there. That is called hypotenuse. After that, here he is saying the labeling of the triangle to calculate in each case opposite to adjacent, like tan ratio and sine ratio. And we have used for this SOHCAHTOA. And what was this? Sine of any angle A, B, C, or theta over there is opposite over hypotenuse. Cos is adjacent. Cos A is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent over there. Will be being taken for calculation of unknown variables in the form of values over there. Okay, here he is saying calculate the value of these tangent ratios, giving your answers up to 3 significant figures. So the easiest way to use the calculator over there, and we can say here that we can manipulate the calculator there, like I am taking here tan 0.5 degree, tan 17.9. I am taking here tan 17.9 bracket close equals to like 0.32. So it is 0.32. You can use calculator for calculation of all of these values over there for question number 1. For question number 2, he is saying for each of the following, find the required tangent ratio of the fraction of letters. Okay, in the form of values over there. As we know, tangent is opposite over adjacent. Opposite over adjacent to angle A. Opposite is 1 and 2 is adjacent. So it will be 1 by 2. Tan A for this one. Opposite is 6, adjacent is 4, then it will be 6 by 4 over there. After that, tan A, tan B. Tan A will be taken as tan A, adjacent 8, and opposite is 2, so it is 2 by 8, which we can say is 1 by 4. And in case of tan of B, opposite is 8, and adjacent is 2, so it will equal to 4 over there. Tan of x. Okay, tan of x, then adjacent is 2.4 and opposite is 3.6. So opposite 3.6 over adjacent 2.4. We will get tan of angle A over there. Tan of z. Z is this, opposite is n over m. And in case of y, m is opposite, n is adjacent, then it will be m over n. From here, tan c. C opposite is a square over a, both one is cancelled, that will equal to a. Opposite over adjacent. So tan is being manipulated for all of these ratios over there. Then now he is saying tan d. Tan d means opposite is p5 over p3. You will get p square for this one. Find the length of the lettered side in each side. Give your answer up to 3 significant figures. Like he is asking for x calculation, it means you can use tan 60 degree is equal to x over 3. So x will equal to 3 multiplied tan 60 degree. 3 multiplied tan 60 degree. 3 multiply tan 60 degree is equal to 3 under root 3 and in decimal form 5.19. Then he is saying 3 significant figure, and then we can say it is 5.20. It is 5.20 farad. Here he is saying again opposite he want to find in the form of y. So you can say y is equal to 8, 10, 30 degree. Just by putting in the same way, you will write here 10, 30 is equal to y over 8. Then 8 is multiplying by 10, 30 and you are getting this form. So 8, 10, 30. Go with 8 multiply 10, 30 degree is equal to 8 under 3 by 3, 4.62. Again, he is saying opposite he want to find in the form of z is equal to 13 multiplied 10, 70. 13 multiplied 10, 70 degree. So you can get the calculator 13 multiplied 10, 70. 13 multiplied 10, 70 will equal to, that is 35.7. 35.7 can be taken into account. After that, again, opposite in the form of P he wants. In the form of opposite, he wants Q. In the form opposite, he wants R. For the last one, I say R is equal to 11, 10, 43. Just by putting into the calculator, 11 multiply 1043. 1043 equals to 11.25, 11.3, 10.3. 10.3 can be taken into account for the manipulation of tan theta for finding the unknown side over there. Now he is saying adjacent is needed. So adjacent is needed. As you know, tan theta is equal to opposite over adjacent. Adjacent you want to calculate in this case. So adjacent will come here, opposite over tan theta. So opposite over tan theta means 12 over tan 30. you will get x. Here you can say again adjacent of y from 43 you need. So y will equal to 15 over 10 43 degree. For this one, I will say here, you want to calculate z again, then it will be 18 divided by, no, he is not asking for adjacent. Here he is asking for opposite over there. So I will use here the previous phenomenon in which z is equal to 18 multiply 10 27 can be taken into account. For D, he is again asking for adjacent. Then 10.8 divided by 1054 should be taken for the calculation of P over there. Here is he is asking for opposite now, and because opposite side of angle is needed, you will use here 13.2 multiplied by 10 72 degree. And for this one, he needs adjacent now. R is equal to 83.3 divided by 10 36 should be taken into account. Whenever you need opposite, then you will have to multiply. If you need adjacent, then divide. After that, here you need opposite over there, then opposite is going to be taken as 12.3 into 10, 12 degree. Just by putting these values into the calculator, you can get your final answer over there. Now you need adjacent, so G will equal to 38.7 multiplied by 10, 22 degree. For this one, you need H as opposite. So H will equal to, you need adjacent in this case. So it should divide. Here you need opposite over there. Here you should multiply. 19.4 multiplied by 10, 64 degree. Are you getting what I am doing? Hello?
जी sir, what
I said, are you getting? Are you understanding?
yes sir.
Okay. After that, here he is saying 1047 is this. Calculate correct to nearest decimeter of, find the value of 1047 correct to 4 decimal places. 1047. 1047 degree equals to 1.07. It means 1 point, he said up to 4 decimal places. So it is 1.0723, 0724. 0724 is equal to 1047 degree. The diagram shows the vertical height of the tree OT. It means I want to calculate opposite over here. And for opposite, I told you that OT will equal to, when you need opposite over there, then remember that tan theta is equal to opposite over adjacent. So adjacent should be multiplied with tan theta. So adjacent is 30, should be multiplied by tan 47. 30 multiplied 1047. So I have this value 1047 multiplied by 30 is equal to 32.17. 32.17. So this is the way how to understand the question and how to implement the trigonometric ratio over that type of question over there. Here he is saying now he need the depth of the liquid over there, and he's saying calculate the width of the river. So this is the width in the form of height over there. Again, you need the opposite to calculate over there. So opposite H is equal to 80 multiplied 10, 22 degree. Just multiply it and get your answer in that case. After that, he is saying that work out the length of AC. Work out the length of AC. The right angle triangle BAC is 30 degree. BAC is 30 degree. And the length of BC to be 1 unit. BC is can be 1 unit. So it is 30. It is 30. Okay. Here he is saying work out the length of AC over there. It means something written wrong over there, opposite, because here he has given degree in the form of length, like length can't be the degree over there. Length always should be taken in centimeter or meter over there. So some mistakenly is done over there. Like he is saying, if let's suppose I say this 30 centimeter and this is 30 centimeter, then this angle can't be 30. This angle should be 45, 45. If he is saying that it is 30 centimeter and just mistakenly written over there, then angle should be 45, 45. But he has written angle 30 over there, then this angle is 60 degree. It should be half, it should be double over there. Like it should be 2 centimeter, it should be 1 centimeter should be taken. So some error has been occurred during the labeling of the diagram over there. So ladder is given. He is saying calculate the distance of base of ladder from the base of the wall over there. In that case, I will say I will have to calculate the adjacent over there. And for adjacent, we know that we will have to do length above and tan of angle like 82 we should write down. Let's go for calculation. Then it will be 3.3 let's suppose fraction introduced 3.2 divided by 1080 degree, then it will equal to 0.56 meters. 56 meters over there. If your 82 angle is in front of this, it means here is only, I will say with the above angle is 8 degree. So 8 degree with the opposite side will have this length that the ladder is 0.56 meter away from the wall over there. After that, calculating angles over there like tan inverse, tan inverse, tan inverse. Now he is using how to calculate the angle. If you are provided with all possible formalities over there, all three sides are given and you want to calculate the angle over there. In case of right angled triangle, for example, you can use here sine theta, you can use here cos theta, you can use here tan theta, as which you remember. For example, you want to take sine of A over there, then it is perpendicular over hypotenuse. So it is 3 by 5. And for angle A, you will say it is sine inverse 3 by 5. Just by putting the value into the calculator, like shift sine inverse fraction introduced 3 by 5, 3 over 5 bracket close, and you will get your answer in the form of 36.86. So this is angle A, which we say is 36 point something. So I will say here the angle is 36.9, as he also has calculated in the form of example over there. You can use your tan, you can use your for tan of B. For tan of B, he used for 12 over 5 for the second triangle in the part B over there. For C, he has used tan again over there. You can use tan, you can use sine, you can use any other value which you want over there. Find the correct 1 decimal place of acute angle that has the tangent ratio this. So it means we will have to go for tan inverse of this 0.85. We will have to get tan inverse 1.2345, tan inverse 3.56, tan inverse 10, and get those values and write those values up to 1 decimal place only. In the second question, he is saying find the correct nearest degree for the acute angle of the tangent ratio. So we will say here, for example, you can take tan inverse 7 by 9, tan inverse 25 by 32, tan inverse 4 to the 8, 3, 11 by 4. I'm doing this for last one, 11 by 4, and I am applying tan inverse also. So tan inverse 11 by 4. Shift tan fraction introduced 11 over 4 bracket close equals to 70.01 or 70.2 or round off, I will say here 70 degree will be taken into account. Find the correct decimal place, one decimal place to the angles of the ratio of their diagrams over there. So here he is saying he needs angle A over there. So angle A will equal to tan inverse. Opposite is 7 over 10. Opposite over adjacent. Always remember tan is going with opposite over adjacent. Opposite over adjacent. So angle B is equal to tan inverse. Opposite is 9 and adjacent is 2. For this one, C and D, if you want to calculate, then how you will go for example, I am going for C over there. Then C is equal to tan inverse. Opposite is 4 and adjacent is 5. 4 over 5. After that, for D, you can go from 180 minus C minus 90. You can also get D over there. But if you want to write it in the form of tan inverse over there, then you will say in front of opposite for D is 5 over 4 can be written for this Snell U over there. F is again, so we can say tan inverse 1 over under root 3 is going for angle F over there. The same case for E over there, we can say angle E is equal to tan inverse 12 is opposite. So 12 over 36 and you will get the value of angle E over there. After that, he is saying the ladder is given with the height and width over there, height and baseline length over there. And you will have to calculate the angle. Calculate the angle the ladder is makes with the ground over there. It means you need this angle over here. So I can say angle for ladder L over there is being taken as tan inverse 8.5 over 2.8 over there. After that, he has shown here width is given and base and height both are given. Again, for tan inverse for calculate the angle of elevation, means this angle he needs over there. And then we can say that tan inverse opposite is 68 over 175 can be used for tangent over there to complete this exercise. After that, here he has shown calculate AM. A to M I need, and I have angle, I have one side, I need A to M over there. And A to M will be equal to, like as an adjacent of tan 40 degree. So I am saying AM is adjacent. The best way is whenever you are going to calculate adjacent, just multiply the opposite side. No, divide opposite side with tan 42. So 12 divided by tan 42 will give me AM length. Calculate AB. AB, just it is doubling the answer which I will get from 12 over tan 42. Wait a second, we do it. 12 divided by 12 divided by tan 42 degree will equal to 13.32. So it is 13.32. For the calculation of full length, it also will be 13.32. If you add both of them to get the value of AB over there, you will write it 26.64 over there. The right angled triangle ABC, hypotenuse AC, means A and C is hypotenuse, and angle B is available at 90 degree. AC is 7. Side BC is 3. Calculate the length of AB and hence the angle ACB also. So AB I can calculate by using Pythagoras theorem, like in the form of x. So x will equal to 7 square minus 3 square square root. Then it can be 49 minus 9, means it should equal to under root 40 degree over there. So not 40 degree, and just only under root 40, and you will get the third side x also. Then you can easily implement ACB, means you need angle C over there. This angle you want to calculate, just apply the tan ratio for both of these lengths, and then write angle C is equal to tan inverse the value of under root 40 divided by 3. You will get the angle over there. Then he is going to do practices with the sine ratio and cosine ratio. For sine ratio, we know that sine theta is opposite over hypotenuse and cosine is adjacent over hypotenuse. For example, here he is saying for each of the following, write down the angle of sine A, cos A, and tan A. For sine A, I will write 16 over 20 for part A. And what I am saying, 16 over 20. For this one, I am saying here, for B, I am going with cos. Then I am saying it should be adjacent, like 24 over 25. For the next one, I can say here, angle A is for 10, I am taking, for example, A opposite is 12. So 12 over 5 is going for 10 over there. So this is the way how to implement sine ratio, cos ratio, and tan ratio on right angled triangle when all the sides are given over there. Use calculator to find these values. Just write cos with the 60 degrees, sine with 85, cos with 85, and get the answers up to 4 decimal places over there. Then he is saying calculate the ratios, like how you will write for sine 42, cos 42, tan 42, as we have done the practice for tan over there. So it's easy to manipulate. Just remember that your sine ratio for any angle like sine 42 will equal to opposite side f over e will be being taken over there. For here I'm saying, for example, he is saying sine 60. Cos 42, he said, okay, cos 42 will be g over e. Then he said sine 60, then it will be opposite c over a. For this one, cos 25. So it is PQ over PR as the ratios of their lengths over there, and sine theta will equal to y over r. Here 848 cos 48 q over r. For here sine 30 e over f. So these are the implementation of the trigonometric ratios over there for different scenarios provided with their sides over there. And we can also implement to find the unknown variable over there. using sine and cos as we have done in tan theta over there. All the scenarios simply implemented just in the style of tan theta or cos theta over there. Here he is saying for each of the following angles, calculate tan x, sin x over cos x by putting 30 degree, 48 degree, and 120 degree. Just place these values in the calculator, and for tan x, you will get directly answer. After that, sin x over cos x, you will get equal answer to tan x, but you will have to go for more steps to solve it and simplify it. After that, he is saying go for their squares and simplify. It's easy one nowhere. Solving the problems using trigonometry. How to apply the law of simple trigonometric ratios in different scenarios. When you are provided the complex figures, you will have to keep in mind that which ratio you will implement to calculate angle or side required for by that figure in calculations over there. For example, this equation number 1 over there, he is saying calculate the angle of ABC. A, B, and C. It means you need to calculate this angle over there. And if this angle is going to be taken into account, then you will use sine of angle B will equal to 5.2 over 18.6. If the meeting ends, then I will start the next meeting. 18.6, and angle B will equal to sine inverse 5.2 over 18.6 over there can be taken into account. So this is the way how to implement the sine ratio and cosine ratio and tan ratio over there can be easily understandable. So I think so your concept behind the trigonometric ratios will be much clarified. And in the next class, we will go towards law of sines and law of cosines over there, which we have